Hi everybody, Eric Hagenberger. I like to find simple solutions to problems. Now, I see a lot of people with problems with supports, and it almost seems like people are spending more time worrying about supports than about their actual prints, either designing them properly or getting them back off without breaking the part. Or maybe they want to make something that's either functional or visually appealing. They don't want to have any supports at all, but they can't print something because of overhangs. They can't print it without having supports. Then I look over in industrial manufacturing. I see these big 6-axis CNC robot centers doing all sorts of fancy things with manufacturing on all different sides of a part at once. And I think we really need something like that in 3D printing. And maybe there are industrial solutions like that out there already. I haven't seen anything in the hobby space, except maybe I've seen a lathe type 3D printer where the part is rotating around and then the print head is printing on that. That looks like a really good start. But meanwhile, let's try something a little bit simpler. I call this fixture printing. And the reason I do, you'll find out afterwards. There's kind of a competition in my family for the kids to figure out which of my jokes was the worst dad joke of the year. And I think this should actually be a winner. So I actually explained this whole thing to my 19-year-old son, just standing in the doorway, waving my hands, and he figured it out right away and started printing. So you feel free to stop the video at any point and just get to work. But first I'll walk you through the steps really simply. This can be done, I use Fusion 360, it can be done in Fusion. You can do this in Tinkercad, and with a little bit of extra work, you can actually do it right in your slicer too. What I'm hoping is that somebody will take the time to program this directly into a slicer, because it would really save a lot of people a lot of trouble. And I don't know why I'm doing this video. I've looked everywhere for, I actually thought this solution was not possible for a long time because I couldn't find any explanations for it. But it's really simple and it works. So here it is, fixture printing. So first you split your part, and then you make a fixture to hold the bottom of the part in position. Then you delete the part from the bottom of the part from the fixture, offset the face just to make a little bit of extra room, and then make some more if you need them. Then merge the top of your part and the fixture as a single component. Then save the bottom and the top in the fixture as two separate STLs. Slice and print the bottom upside down. Then slice the fixture and the top, print them together with a pause in between so you can insert your bottom part. And there you go, it's all taken care of. So now let me show you how to do this in Fusion 360 first, and hopefully that will be enough to really get you on your way. Okay, so I've got this part here in Fusion 360 that I would like to print, and it's this main part here that I would like to print without support. So let me just remove some of these other bits here that I don't need right now. So this is the part I want to print, and as you can see, basically no matter what orientation I try to print it in, I'm going to end up needing some sort of supports. And so what I'll do here is first just split this right down the middle into two parts. There we go. And then let me just get rid of the top for the moment. Focus on the bottom. And then what I'll do here is to make a couple of fixtures that will just hold this in place. So I can print this upside down. So it'll be this way on the bed. So I'll make it upside down, and then flip it over, put it in the fixtures on the printer, and then continue with the top of the part. And okay, in this case it might not be necessary. I don't necessarily need to do this without supports, but I want it to look a little prettier, so we'll do it this way. Now, the first thing I'll do is to there's millions of ways to do this, obviously, in Fusion 360, but I'll just make a box here, and I'll define as my plane to start with just this the bottom of this here, and then just draw a little box like this. Let's see, did I get it? No, that's kind of off a bit, so I'll move it over here. There we go, and up like that. Maybe a little higher to make sure I'm actually catching the whole thing. That looks pretty good. And now, obviously, I don't want to cut here. I want to make this as a new body. Okay, so there it is. And then I want to delete the part itself from this box that I just made, from this fixture. So to do that, I'll just say split body, and I'll select this as the body to split, and then I'll select this as the tool, and then OK, that should take care of it. Now if I just hide this, you can see I've taken just a little chunk out of this here, and let me remove that because I don't need it. And then what's very important when you're doing this here is, obviously, if I printed this just as it is and then tried to fit that part in there, it wouldn't go because it'll be too tight a fit. So what I'm going to do then is to say offset face, and let me just grab all these different faces here. And one more. Oh, it looks like I got that one already. 1, 2, 3, 4, I guess. Okay. And then I'll just offset that by, I found that 0.1, so minus 0.1, 0.1 millimeters works pretty well. That may depend on your particular printer. And then I'd like to have 2 of these, so what I'll just do is to mirror this across the axis, or across this XZ plane, I guess it is. So then I've got 2 of those, and then I'll do the same thing on the other side, just to make sure I've really got this fixed in position. That's why they're called fixtures after all. So I'll do a cylinder this time here on this plane, and just start it like right about there and go out a little bit, and then obviously up, not down, like that. And again, make it a new body. Okay. And here again, I want to split body. This is the body to split, and this is my splitting tool here. Okay. And then if I just hide this, again, I'll select some of these faces. Oh, first, let me just remove this because I don't need that. and then modify offset face. It looks like I've already got, have I got one selected? No, actually I haven't. So need that, and that, and that, and again minus 0.1 millimeters. And again, let me mirror that across to the other side. So I've got a full set. Mirror this over this plane here. Good. And then if I show the part again, you can see that'll fit neatly into those when I print. But you can also see clearly there's a little 0.1 millimeter gap, and it'll be a nice tight fit. It seems to work out pretty well, at least on my printer. So then the next thing I want to do before I go and slice and print this is, okay, it's no problem to take this bottom part. I can export that, save it as a mesh, STL, and just save that as I'll call this the bottom. That's saved. And then I want to take the, whoops, what was it? This piece here. Then I want to take this and actually combine all of these. And this is just because otherwise it won't export as a single STL. So take all of these bits here, okay, and combine those in a new component. All right, then here's my component, and then I can save that as a mesh. Okay, and we'll call that top and fixtures. Good. Save that. And then basically I'm done. Now, before we go any further, though, I just wanted to show you one thing. Obviously, this method works great for some things, but there's other things where I think you'll be able to see that, for example, this come on. Let me see. There we go. So this piece here. What if I wanted to split this somehow and print it? And I think you can see that. Well, yeah, I could split this horizontally. Like this. And then that might help me a little bit, but no matter how I do it, or the other possibility would be, of course, if I were to split it along this plane here. But look at what happens if I do that. And here you can see the limitations of this technique, because even if I go ahead and cut this in half and then try to print one part and then the other part, I'm still going to end up with an overhang. So basically what it is if you've got an internal overhang, I guess you'd call it, or an overhang over the part itself, and it's not getting smaller towards the top or smaller towards the bottom, then you're a bit out of luck, actually, and you may have to use supports. As a matter of fact, I printed this with this orientation here because I wanted to have the layers perpendicular to the axis of rotation, and I printed this up, and it actually came out fine. So basically, from here now we go to our slicer, and let me just pull that up. So we'll start with the bottom here. And all I have to do with this is to just flip it over and print it and slice it. Now you can see, of course, that yeah, we're still going to have some issues here, but it'll print up fine. Those are bolt holes, so they can be drilled out if necessary when we're done. So I go ahead and print that, and then once that's done, I'll just remove that and pop on this top piece with fixtures here and slice that. And what you can see now is obviously I'm going to end up with some errors here. Yeah, there's always print stability issues, but I don't know, my printer always prints things fine, even though I have these print stability issues. But it says here empty layer between 13 and 20.2. Now make a note of that 20.2, because that's actually going to be really important. So what we'll do is insert a pause right at the very first layer where it's starting to print the top. And I'm going to insert a pause right there. So I'll tell it add pause. And if you want to say something different, like put bottom on and continue, or whatever, doesn't matter. But anyway, there's that pause there. And so what's going to happen then is I'll print this, and then the printer's going to pause and ask me to put in your bearings or whatever, and then I pop in my bottom part into this fixture here, and then it goes on to print the top, and then it's done. So that's all there is to that. Now, just a note of caution here: if you're not really familiar with how this works, you might just want to, before sending this straight to the printer, you might just want to check in your G-code, look for this M601 pause, and make sure that it is at the very start of that layer here where it says Z20.6. Put bottom on and continue right there, M601. So it's going to stop right there at the 20.2. This is really important because first of all, you don't want your printer to start printing the first layer of the top before you've put the bottom in place, nor do you want to have it pause before it's done working its way up to the right level, because otherwise you're going to be driving the print head straight into the bottom that you've just put in place when it's supposed to be printing on top of that. And you can think about how I know that you need to watch for that. So now I've printed the bottom part upside down, and I'll take that off and then start printing the supports. And then once those are done, I'll pop in the bottom part again, and I'll stop speaking here so you can actually hear it click in place. It's very satisfying. Now, one more thing I just need to warn you about here, which I mentioned at the beginning, is that if you're using Octoprint and you haven't already inserted the proper G-code for a pause, you need to manually reset your extruder temperature. Otherwise, it's not going to be extruding. So that's just one other thing to watch for. And I still haven't figured out how to do that G-code in Octoprint. It seems like everybody knows how, but nobody actually explains just what you need to put in there to get that temperature back up after a pause. So then I start printing the top on the bottom, and I put this in two different colors just so you could see what's actually happening here. And it also looks interesting if you look in the pretty G-code. You can see it looks like it's printing in air, but of course it's not. Now, this isn't the only application for this method. You could also put something new on an existing part. You could use it to rescue a failed print that you don't want to start over. Or you could continue extending a part at multiple angles in several steps. So lots of interesting applications. So then there's the finished part. As you can see, it's It's a nice transition. None of the artifacts that you'd have from putting supports on. No need to pull supports off. And then in case you're wondering what this was actually for, as I mentioned at the beginning, I like to solve problems. This was an idler pulley just to keep this cable on my exercise machine from jumping off the big pulley. So there's no actual load on it. It works just fine. So that's all there is to it. Hopefully this helps you to print some of your parts a little bit neater and cleaner. And now we get to the, well, I hope I win the Dad Joke of the Year award for this, because as mentioned, I call this fixture printing, because you're printing fixtures that fix your print in place, and that fixed your printing. So thanks for watching all the way to the end.